All right, so I wanted to walk you through example 1 on your 1.14 worksheet 3, linearization practice. So you have a set of data here, and it always lists the x values or independent variable on the right side, and then the next column are your y values or your dependent variable. So we're going to need to open up Desmos here, which I have open already, so that we can graph this. So in order to make this table in Desmos, click on the Add Item, the plus symbol at the top left corner. We're going to choose Table. So again, the first column are the x values, second column are the y values. So we just need to type in each of our values here. Then do all of the y values in this column. And as you can see on the graph, these points that we put in the table are appearing. So we can click and drag the axes where we want them. But we also want to zoom in a little bit. And you can either use touchscreen and zoom in or out just by pinching or spreading. But if you want to change just one axis or another, you have to grab specifically on the axis that you want to stretch or compress. So if you put both fingers on the vertical axis and stretch it up, like that. Now if you don't have touchscreen or you don't want to do it that way, you can also go up here to the tool or graph settings, and you can change your maximum and minimum x and y values here to change your window. Okay, but while we're in here, we also need to add axis labels. So on the x-axis, that was our first column over here. So that's v, and then in parentheses are the units. And to do exponents, just use a caret. This is volume in meters cubed. And the y-axis over here, p, this is pressure. And that is in units of PA, which is pascals. Okay, now we have axis labels. We can click on the settings here to change that window out. You can see a nice curve here. So we need to take a screenshot of this graph, or if you go up here to share, click on that. We want to export the image. I like to choose medium thickness just to make the lines more visible, and then download. So that's going to end up in your downloads. So then over here, when you need to insert your original graph, go up here to Insert, Image. You can upload from computer if you're on a computer, or your drive, wherever your downloads are. So I'm going to go to my downloads folder here, and it should be the most recent item that I made. Boom. Okay, so next we now need to look at the shape of this, and we need to decide what do we need to do to the data in order to linearize it. So let's take a look at our linearization table summary from 1.13 notes. That's this one here. And we need to match the shape of this graph to one of these options here. And it's a nice slide or scoop down, so that's this graph. So as x increases, y decreases. So this column here tells us modifications required to linearize graph. And for this shape, we need to graph y versus 1 over x. 1 over x is the same thing as x to the power of -1. So that's what we're going to be doing. So v were our x values. So we're now going to be graphing 1 over v. And since the units were m cubed, meters cubed, it's now going to be either 1 over m cubed or m to the -3. Either option. And you can leave it like this, or you can go up to format and change it to exponent. There's a short key to that if you like. So there's a negative in front of that 3. Kind of hard to see there. Okay, then using Desmos, we can calculate what all of those values are and enter the new values in here. So you can do this on the table, raised to the power of -1. We need to do that for all of our x values. So I'm doing caret, which brings it up to the exponent, -1. Or you can use your keyboard here and push this. So this brings it as an exponent, and then type -1. We need to do that for all of the x values. And you notice it's changing on the graph as we're changing these values. And it should be becoming linear. It's a little bit hard to tell here because it's rather squished. So we're going to put our fingers on just the horizontal axis and stretch it. And we're doing this so that we can really see the data. And then maybe adjust it a little bit left and right so that we can see it. I'm going to zoom out just a little. Yeah, that looks nice and linear. So we do need to change our axis label. So we, instead of doing just b, we changed it to 1 over. And you can either do 1 over or to the power of negative, your choice. It means the same thing. Okay, so don't forget to change your axis label once you linearize your data. Now we also want to include a line of best fit. So if you don't know how to do that, under the graph here, type y and then the number 1. It automatically makes it into a subscript. And then we want this tilde, the squiggly. That means approximately. And then we have mx1. If you want, you can do plus b. You don't have to do plus b because it goes through 0, 0 on this graph in particular. This is a perfect fit. Most likely this was contrived data, not actually taken from a lab, or it was a very carefully measured lab. So either way here, we have beautiful linear graph. So we are going to need to insert this graph. Let's go to share, export image, download it, and then on our worksheet over here is where we need to insert our image that we just did. Insert image. Again, mine's in my downloads on my computer. Right here. It's a beautiful linear graph. Okay, the reason we do this is now we can tell specifically what the relationship between the variables are. And that is because we now know the slope of our graph. But before we do that, we have to include all of our values here for the linearized data. And you can choose if you want to actually calculate what is the inverse of 0.1. Or you can just do 0.1 to the power of -1. I'll let you choose. For the sake of time here in this video, I'm just going to copy all of these values and paste them all in here. And for each, raise it to the power of -1. Again, you can leave it as that, or you can format it so that it is an exponent. And I might go through that and do that after making the video. Okay, underneath the table here, it wants to know what is the mathematical equation or expression. Now, instead of using x and y, we want to use the variables we're given. So our y variable is P for pressure. So we're going to type P equals, and then the M value that we got from our line of best fit is 4. And then our x value, what we graphed here, is not just v, but 1 over v. So in parentheses, 1 over v. And if you want to write +0, you can. You can leave it off, your choice. I'm going to underline this just so it's easier to see. Okay, so our relationship that we found is pressure is equal to 4 times the inverse of the volume. Okay, last part here is, what is the meaning of the slope? The meaning can be a little bit tricky at first, but what it's saying is that as the inverse values of V are changing, the pressure values are changing, proportional by a constant of 4. That sounds like a very mathematical explanation, however. So we're going to write it in terms of our variables, volume and pressure. And if you don't know what these letters represent here, you can just use the letters instead of the words. Because in the future problems, there might be some ones that you don't know, which is totally fine. So we're saying that P, or pressure, is inversely proportional to V by a factor of 4. Meaning, as the inverse of volume increases, the pressure decreases by 4 times that amount, or something to that effect. So try all the rest of the problems on the worksheet, just like this. Use your summary table to identify what type of relationship. And at the end of the last 2 problems, they might be a little more challenging because you might have to do more than just one step. Try one linearization step, and then you'll see a change in the graph that's not quite linear, so you might have to change it one more time. But if you get stuck on those, no worries. We'll go over all of this in class on Monday or Tuesday.